Hello, everyone, and welcome. My name is Liz Temper, and I'll be your moderator for today's WJE webinar, Finding Appropriate and Effective Cleaning Solutions for Historic Facades. During the next hour, WJE historic preservationists Kyle Normandin and Deborah Slaton will address cleaning techniques for different types of materials and substrates encountered in historic structures. They will discuss how to effectively evaluate cleaning products and systems, including water, chemical, and microabrasive, and will explore specific challenges encountered with facade cleaning projects. This presentation is copyrighted by WIS Jenny Elsner Associates. And now I will turn it over to Kyle to get us started. Kyle?
Thank you, Liz. Good afternoon, everyone, and thank you for attending today's webinar entitled Finding Appropriate and Effective Cleaning Solutions for Historic Facades. Today, the presentation will be given by both Deborah Slaton and I. Deborah is an architectural conservator and principal here at WJE. She specializes in historic preservation and materials conservation. She has served as a principal author of numerous investigative and preservation publications nationally and internationally. My name is Kyle Normandin, and I will join Deborah today as a co-presenter. I'm an associate principal at WJE and also an architectural conservator. I've investigated many types of buildings and materials with a principal focus on architectural conservation of masonry structures. So, finding appropriate and effective cleaning solutions for building facades is often not just necessary for aesthetic reasons, but often promotes good maintenance practice overall. Most cleaning of moderately soiled historic building facades is also performed as soiling may obscure architectural detailing, including colors of the building facade. However, in many cases, severe soiling may also affect the long-term maintenance and stewardship of a building or historic monument by concealing open joints and structural deficiencies, such as cracks and even incipient spalls. Some types of soiling, for example, ones involving the development of gypsum crusts or even acid-secreting biological growths, may actively contribute to deterioration on different types of substrates. Many argue that soiling combined with interrelated patterns of surface erosion are also part of the historic appearance of the structure. In some cases, it may be a challenge to differentiate harmful layers of atmospheric or pollution buildup and soiling from patinas. That actually, all of these things might contribute to the building's historic character. As you will see in this presentation, the primary reasons for cleaning a building facade may vary. It is good preservation practice to select the gentlest, effective cleaning method for many types of structures. In establishing criteria for facade building projects, a careful consideration of the nature and composition of the material and substrate is always a key factor, including the identification and nature of soiling. When selecting an appropriate cleaning method, it is critical to evaluate the susceptibility of different substrates to different cleaning processes so that unnecessary damage is not introduced to the historic material substrate. So moving ahead now, here are the learning objectives which were circulated in the announcement for today's webinar as part of the AIA Continuing Education Credit Program. As we jump right into the webinar, today's program will consist of the following components as part of the presentation. We will first start with the goals and criteria for facade cleaning programs and also discuss some of the basic philosophies utilized based on guidelines and lessons learned from cleaning programs of preservation of historic buildings here at WJE. We will then move into a brief discussion on types of substrates typically encountered on buildings, including representative types of soiling, followed by 4 categories of cleaning systems. Towards the end of the presentation, we will just discuss how to specify some of these systems based on types of substrates and soiling, and we will then review ways to implement successful solutions, and then present a case study that represents a cleaning program that was developed as part of a redevelopment project for a modern historic structure. And with that, I'd like to hand it over to Deborah to take us through the goals, objectives, and establishing criteria for the cleaning program.
Thank you, Kyle. As background to any facade cleaning project, our first step is to consider, why are we cleaning? What are the goals of the project? The goals may be to remove deleterious contaminants, to prepare the substrate for repairs, or simply to improve aesthetics, or all of the above. Cleaning can comprise the focus of a facade project, or it can be a part of a larger repair or preservation effort. And cleaning is often a cyclical maintenance task. So keeping in mind all of the possible goals we may be seeking to achieve, how do we establish criteria for cleaning the facade? We need to understand the materials being cleaned, the soiling and stains to be removed, and the context. For example, what environmental constraints pertain to the cleaning project? Is it in a metropolitan area where cleaning may need to be performed only at night? Is cleaning with chemicals restricted by local ordinances? There can be many, many context issues. And finally, in establishing criteria, it's essential that everyone on the project team communicate. The owner, who needs to articulate the goals of the project, the professional team, architect, engineers, conservators who are designing what's going to be done, and obviously the contractor and subcontractors who will be implementing it. As part of establishing goals and criteria, an important question is to consider, what is the required level of cleanliness? The goal of the project is not necessarily to return the facade to a like-new 100% clean condition, which may in some cases involve damage to the substrate. This example shows 3 different cleaning trials on a terracotta and granite facade, in which we're seeing a range of under-cleaning to over-cleaning, and then an acceptable midpoint. And trials, as we'll discuss further, are really essential part of establishing expectations. Is cleaning the facade of an historic building different than cleaning the facade of a non-historic building? Not really. The overarching goal in both cases is to remove soiling and staining without damage to the underlying substrate. The Secretary of the Interior Standards for the Treatment of Historic Properties offers guidance that is useful for both historic and non-historic structures. Let's look for a moment at one excerpt from the standards. This quote is particularly pertinent to facade cleaning. Chemical or physical treatments, if appropriate, will be undertaken using the gentlest means possible. Treatments that cause damage to historic materials will not be used. We consider this equally valid for non-historic facades and for really any facade cleaning, no matter the age or significance of the building. Setting goals and criteria for facade cleaning projects helps avoid problems during and after cleaning. Cleaning with the wrong products or techniques can cause damage to the facade materials, and sometimes this damage is irreparable. For example, cleaning with strong acids or aggressive abrasives can damage the surface texture and increase absorption, and also cause soiling to accumulate more rapidly. And this would then result in a need for increasingly frequent facade cleaning efforts. In addition, this type of distress can lead to a deterioration of the material over time. The examples shown here on the left are 2 aggressive acid cleaning. The one at the top left etched the granite, and the example at the lower left mobilized ferrous staining in the stone, which had to then be addressed years later by further cleaning. The examples on the right show abrasion of brick masonry where the surface has been pitted or actually completely eroded. In these examples, high-pressure blasting with an abrasive media such as sand was used in the past history of these buildings. High-pressure blasting and use of sand on masonry facades is no longer considered appropriate. And Kyle will talk further about micro-abrasives, which are a different category of cleaners, in a little while. With the goals and criteria in mind, let's look at the methodology for facade cleaning projects. As discussed, we establish criteria and understand the nature and condition of the substrate and soiling. More on that in a moment. We evaluate possible choices of cleaning systems, develop small-scale trials, prepare the contract documents, perform large-scale cleaning mock-ups, and evaluate those mock-ups, refine the cleaning procedures, and provide quality control during cleaning. This flowchart illustrates the process for facade cleaning. If you begin with the start symbol and move straight down the flowchart, you can see that the process with successful cleaning trials and large-scale mock-ups can proceed directly to implementation of cleaning, shown at the bottom right. However, as you'll notice, at several points in the flowchart, for example, if the cleaning trials or mock-ups are unsuccessful, we return to the top of the flowchart and begin the evaluation, trials, and mock-ups process again. And we always have the option shown at the top right of not cleaning. If cleaning cannot be performed successfully without damage to the substrate, then the extent or degree of cleaning may need to be limited. Keeping that in mind, let's talk for a moment about substrates and soiling. We need to understand both in order to select an appropriate cleaning system and technique. The substrate is the surface or material being cleaned, and it can range widely on building facades. The image at the left is exposed aggregate concrete, which is particularly interesting because it contains a number of materials. It contains Portland cement, sand, and several different types of stone in the aggregate, so each type of material may respond differently to cleaners. And on the right is a photomicrograph of soiling on a substrate. Laboratory analysis such as microscopy, scanning electron microscopy, or X-ray diffraction can be used on small samples taken from the facade to determine what the soiling is. This isn't always necessary, but it can be very helpful in understanding what's causing the soil or stain and how it can be removed. Field microscopy is also an important tool before and during implementation of cleaning. There are 4 broad categories of facade cleaning systems: aqueous or water and steam systems, chemical systems, which include a very wide range of products, as well as paint strippers and biocides, micro-abrasive systems, and laser cleaning systems. I'm going to walk us through the first 2 categories of cleaning systems, and then Kyle will continue with the latter 2. Water and steam systems can range from very low pressure water misting to moderate to high pressure. And keep in mind that water is almost always a part of chemical cleaning systems, and it's sometimes a part of micro-abrasive systems. Very low pressure water misting has been found to be effective on limestone, marble, and some cast stone and precast facades. The example shown here is a very fine water mist delivered from a spray rack, and this water mist is effectively removing the soiling from the stone. Another example shown here on the New York Public Library is a very complex spray rack developed to address the very complicated facade, and again, before and after photos. Water pressures for cleaning vary from very low, less than 100 psi, to high pressure. In facade cleaning, we're most often in the very low to low pressure range, and this varies depending on the substrate. Similar to water cleaning, steam cleaning can be very useful for stone substrates and can be used in combination with detergent. Proprietary steam equipment, as shown here, is portable and can be used on scaffolding. Steam systems, of course, require safety precautions for the worker. In summary, water cleaning systems range from very low to high pressures and also include steam techniques. Low pressure cleaning systems can remove atmospheric soiling from marble and limestone. These are gentle systems and don't require extensive protective measures, but they do involve a lot of water. Now, a brief overview of some chemical cleaning systems. Chemical cleaners react directly with dirt or with the substrate to dissolve soiling and staining so they can be rinsed away. And as mentioned, many chemical cleaners are used with water. Detergents are typically mild cleaners and can be used on a range of substrates from masonry to metals. There are many alkaline and acidic cleaners. Sometimes the alkali cleaner is followed by an acidic neutralizer. Acids range from mild organic acids such as citric and acetic acid to stronger acids such as phosphoric and gluconic acid. Some strong acids can damage building materials. More about that in a moment. And chemical cleaners can be used in poultice form. They also include paint strippers and biocides. Here's an example of a mild citric acid cleaner successfully used to remove soiling and streaking from brick. The photo on the right is a trial area, uncleaned on the left, half of the photo cleaned on the right. A special caution about acidic cleaners. The chemicals listed here are hazardous to people and also can damage masonry substrate. These types of acids can dissolve silica and other siliceous components, corrode embedded metals, mobilize ferrous staining in granite and concrete, and cause other problems. So for any cleaning product, be sure to review the safety data sheet as well as the manufacturer's product literature to learn what's in the product. As mentioned, chemical cleaners can be used in poultice forms. Poultices are an inert material that can be combined with a chemical to help draw out deep-seated stains, and these can remain on the surface for 24 hours or longer. Some poultice media used traditionally include diatomaceous earth and adipalgite clay. Some newer poultices include natural latex rubber. The example shown here is a waterless poultice. The top left photo is an area of a limestone facade before cleaning, and the bottom right photo is after cleaning. You can see the steps during which the poultice was applied, rinsed, removed, and then the surface dried. Another example here of a rubber poultice on two different substrates, and you can see it was quite effective. Another class of paint strippers is another class of chemical cleaners is paint strippers. They are applied to remove existing coatings prior to repair or recoating, and also to remove graffiti. In this example, a chemical paint stripper was used, and then the surface touched up with a micro-abrasive, which Kyle will address. Proprietary paint strippers include a range of chemicals. Some are health hazards. We avoid specifying those. All require safety precautions. graffiti presents a particularly challenging paint removal issue. Here's before and after of graffiti removal from a brick facade. Brick can be very difficult to clean if it has a rough texture. And you'll note that the graffiti is really completely gone. It's a very successful effort with a chemical cleaner here. And one key to getting graffiti off the substrate is to try to make the cleaning effort as soon as possible after the graffiti appears. And finally, biocides are another type of chemical cleaner. Biological growth on building facades often occurs in areas that are shaded or remain wet, and it can include lichens, algae, and other growth. Many cleaning products will remove biological growth, but biocides remove the growth and help inhibit its reoccurrence. And you can see a successful biocide trial in the image on the right. So in summary, chemical cleaning systems include a very wide range of products and application techniques. They can be effective in removing soiling and staining, especially from substrates where water and steam methods are not as effective. For example, brick, terracotta, and concrete. They can be very effective, and biocides offer ongoing deterrence of biological growth. However, protection requirements can be significant with these systems, and inappropriate use can result in damage to substrates. So I'll turn the presentation back over to Kyle, who will talk about our other two categories of cleaning systems.
Thank you, Deborah. Microabrasive cleaning systems have come into use over the last 3 decades and are used on a wide variety of projects. Systems like sandblasting are not considered microabrasive systems. Microabrasives use very low pressures and special media. This allows for a variety of adjustments, as you can see here, through the use of various fan tips, which can direct the use of the media during the cleaning process. Similar to the adjustment of water and media ratios, the tips can be changed out to allow for the possibility of cleaning of a variety of substrates. Here you can see a photo of the Rotec nozzle away from the substrate. Typically, we like to encourage at least 10 to 12 inches away from the surface prior to cleaning. Selective microabrasive cleaning systems can also be utilized on a project in areas where, for example, marble stone remains in good condition and exposed surfaces reveal light to medium soil accumulation. In some cases, silica-based media can be used with the Rotec microabrasive system and can be adjusted so that a greater percentage of water delivery is mixed in with the particulate media. A greater amount of water in the mix with the cleaning media oftentimes is found to soften the impact of the cleaning media onto the substrate while proceeding with a slower rate of cleaning. This allows for a greater degree of control throughout the cleaning process. Here you can see that there's a photo of cleaning on the left in progress, and then on the right, there's a photo after cleaning. Additional examples of Rotec cleaning are commonly on granite soil substrates. In this case, at the base of the building, there was lots of exposure to pedestrian and vehicular traffic. Note that the operator on the right is wearing full protective gear and working at a low pressure in close proximity to the base of the building. The image on the left shows a clean substrate. This is a progress photo of another granite building. However, the media of choice in the cleaning system is a sponge jet. And on this particular project, it was used to clean an alteration crust on the granite, which was caused by previous cleaning with strong acid. Here you can see on the left the sponge media being applied to the substrate, and then the cleaned area on the right. And finally, the last example of microabrasive cleaning is a more newer system, which has actually been out quite some time now already, is the EVIC system. Here is an example or a trial on concrete. Mock-ups were carried out to understand the effectiveness of removing graffiti. A calcium carbonate media was used at a very low pressure of 12 psi. So in summary, I think it's pretty common to say that micro-abrasives cleaning pressures are typically between 5 and 130 psi, which is really quite low for successful results in cleaning. These systems also provide the deep cleaning of different types of substrates using these bracketed pressures. Some of the pros of the systems are now pretty portable, and they can be set up on most job sites so that you can actually get them to accessible platforms on pipe frame scaffold, for example. Some of the cons: containment can be challenging, and it should be monitored, as media particulates sometimes go outside the work area. In fact, we often encourage the use of vacuum attachments, which can be used on the EVIC system, for example. And now I'm going to talk a little bit about laser cleaning systems. In 2001, WJE began a review of a variety of ND-YAG lasers, which we've been looking at over the last 2 decades. ND-YAG lasers were used to carry out different cleaning trials on different stone specimens. Our evaluation included the use of Q-switching, which is a short free-running ND-YAG laser on selected Indiana limestone samples removed from decorative ornamentation with different levels of soiling. Here you can see the handheld portable ND-YAG laser device using laser light to remove heavy black gypsum crust from the limestone samples. Based on this process, I think it's important to really keep in mind that several parameters are often used to monitor the use of the laser beam, including establishing a material ablation threshold, which is basically the required energy needed to remove the soil deposition safely without burning the object. There's also the energy per pulse, which is often referred to as the fluence. The energy density, or the laser beam as we often refer to it, is the energy unit per area on the surface. It's really a measure of how concentrated the energy is in the laser beam. And then finally, the beam size is very important because that's actually going to cover the area of which the object is being cleaned. So just remember that the wavelength and the pulse length are often set, and then the fluence must be in high enough degree to remove dirt particles so that it's not too high that the object is damaged in the process. With that, I want to just briefly take us through a few figures to show some of the more fragile stone substrates that we have used to clean using lasers. The photo at the left is the formed black crust on an unclean portion of marble. And the photo on the right, you can see a broken cross-section. In that photo, you can clearly see that the dark dirt gray surface crust is clearly visible on the top, which is underlaid by a yellowish friable marble. The next step is that once the specimens or fragments are evaluated off-site, small trials can then be carried out using the information documented on the smaller samples. And then here you can see that the sculpture of the pediment sculpture, here you can see the pediment sculptures at the New York Public Library. A range of settings was evaluated to understand the minimum and maximum fluence rates, including the rate of repetition used to expose the surface. The larger test area is on the lower right, represent the evaluation of efficiency rates to understand how long it would take to clean the particular areas involved. These were basically approximate timeframes that could be established for the overall cleaning scope in this project. And here I just wanted to show you a quick video so that you could see the rate of repetition of the laser light across the surface and some of the areas that are being cleaned. It actually works quite quickly, although the size of the beam size on the surface is about the size of a dime. So in summary, laser cleaning methods are really quite good because they don't use any chemical products, which makes it one of the safest cleaning solutions. A one-person operator can work safely on most laser cleaning machines. Some of the pros: laser cleaning methods vaporize the soil layer to be removed, and there isn't really any runoff, and therefore very little containment is typically needed. Some of the cons: well, laser cleaning systems still remain costly and expensive compared with other cleaning systems presented here today. However, the laser cleaning systems don't use a lot of water, and in the long run that may become an issue in many metropolitan areas and even areas in other parts of the country. So that, together with less containment, may drive the cost of this particular system down. It's important to note that laser cleaning is still considered a specialized cleaning system, mainly used for work on fragile masonry and metal substrates, which require careful consideration in terms of historic materials, including sculptures and sometimes interior finishes. And with that, I'd like to hand it back over to Deborah, who will take us through design and implementation of cleaning programs.
Thank you, Kyle. This will just be a brief overview of some issues in design and construction documents and implementation of cleaning projects. In any construction project, as mentioned, cleaning may be the focus of the project, or it may just be part of a larger effort to repair, rehabilitate, or preserve building facades. In either case, the drawings for the cleaning work will show the extent of work, define the areas and substrates to be cleaned. In some cases, if cleaning is only of localized areas, we might extend the definition of areas to be cleaned to include the wall extending to an architectural feature, such as a water table, so that it doesn't appear different from immediately adjacent areas of the surface. The drawings also define areas for cleaning samples and obviously dimensions and quantities for bidding. Specifications address key issues such as contract qualifications, site and temperature constraints for the work, protection and disposal requirements, which in some cases may require collection of the cleaning debris and rinsate, as well as the products and systems, how they're implemented, and quality control. A few more words on quality control, which is really key to a successful project. This can include laboratory and field studies of the materials. It can include field microscopy during the cleaning to confirm effectiveness and that the surface is not being damaged. Obviously, samples and submittals, trials, and then large-scale mock-ups, such as the example shown here on a granite facade, and then observation and testing during cleaning. We really can't overemphasize how important trials and mock-ups are as part of quality control. The small-scale cleaning trials allow us to narrow the number of cleaning systems that will be used. They help the contractor understand logistics and how many recleans may be necessary to achieve the desired result, and they allow the entire project team to understand what the outcome will be aesthetically. The cleaning trials are evaluated visually and also with field microscopy, and the results are documented for reference. Cleaning trials can be performed prior to the overall work when the specifications are being developed. Generally, that's extremely advantageous. The large-scale mock-ups can be performed at the start of work and then retained throughout the work as a reference for the entire project team. And to illustrate the entire process, I'd like to turn the presentation back to Kyle, who will give us this case study.
Thank you, Deborah. Today we wanted to also present a case study as part of this presentation that was a project that was part of a large rehabilitation for the Sacramento Municipal Utility District headquarters in California. The building is a historic, modern building originally designed in 1959 by the Office of Dreyfus and Blackford. Our role on this project was the historic preservation consultant, and also we had components of the work that included building envelope and other types of consulting, as well as the development of different reports. Some of the building envelope investigative scope included reglazing the window walls and waterproofing and cladding restoration. This case study will focus on the cleaning of the sanfordized aluminum spandrel and sunshade systems, the precast concrete mosaic panels, and the glass mosaic tiles, which are at the columns at the base of the building, as well as the mural. This is a photo of the completed building shortly after construction from the west face. The north wing is in the foreground, the south wing is in the background, and the core of the building is in the middle. The north wing had a parking level and additional office space above, and the core housed the main stair and elevators. Note that the window walls on both wings face north and are not shaded. As you saw in the prior slides, one of the main features of this building is the aluminum cladding and the sunshades. During initial site visits, WJE documented some areas of localized corrosion of the aluminum where the anodized layer no longer existed. This included dirt and other surface deposits. It was determined early on that the waterborne dirt deposits, including some of the anodic corrosion, was occurring based on our prior experience with other types of projects like this. Close-up field microscopy confirmed localized pitting conditions. We could observe pitting in the anodized aluminum substrate. Here you can see waterborne corrosives at pit sites along the surface. As we all know, once the pitting begins, there is no way to really replace that anodized substrates in that particular area. One of the conversations that we had to have early on with the client was really to set some expectations about different approaches. The two approaches that we discussed with them were the first, which was to take a very maintenance approach, which could achieve a like-new appearance, but would not be too restorative. As part of this process, we could include localized treatments also to help with some of the pitting and corrosion observed on the building. The more intensive intervention would be more restorative, and the aluminum panels would have to be recoated. But the panels were overall in very good condition, and this treatment seemed a bit soon to be undertaking. For the project, a maintenance-based approach was selected, which included cleaning of the original surface to preserve the original appearance. Selective coating of soffit panels was undertaken as well, but only where needed, so as to have minimal impact to the original color and texture. Localized pitting was addressed where needed, and a clear seal was provided in only areas that exhibited the pitting after cleaning. There are many prominent features of this building, but the one everyone is able to interact with at eye level are the mosaic glass tiles at the columns directly in front of the mural by Wayne Thiebaud. For many years, hard water overspray from the in-ground sprinkler system had sprayed the column areas just outside the breezeway, and over time, this caused calcite deposits along the surface of the glass tiles, as you see here on the photos on the right, represented by a white haze or cloudy appearance. Close-up views of the calcium deposits across the tiles were helpful to confirm that these areas could be cleaned after the calcium deposits were softened using water and then lightly abraded from the surface. Small cleaning trials were performed here, as you can see in the photo in the center. The photo at the right is a photograph of the 1-inch tile in the center. The underlying glass tile substrate appeared to remain intact after the small cleaning trials were performed. Larger trial cleaning methods were then ultimately settled upon, where the procedure of water misting and a very low pressure microabrasive was used, about 15 psi actually, to remove the white scale surface deposits. In addition to cleaning the tiles, we also had a cleaning program for the concrete MOSI panels, which were located at the top of the building. These panels were highly textured with exposed aggregate panels, and they were originally installed after the original aluminum framing was in place. As seen in the photo, the rust-colored staining was quite apparent initially, which affected all the facades relatively equally, and there was really no discernible pattern in terms of the staining locations. Once we were able to get up close on the panels, we noted that dirt and soot was uniformly spread across the surface. Slightly more soiling was found on the south wing, as it had a closer proximity to the freeway. The rust color staining was in fact a ferrous metal inclusion within the aggregate and not near the surface where the reinforcing bars were present in the panels. Cleaning trials using laser cleaning systems and more traditional hand washing was performed. Here you can see some photos of the laser cleaning trials and the fact that there was no damage even across the blue painter's tape. On our panels, the laser treatment removes slightly more of the soiling than the traditional forms of cleaning, but they also greatly reduced the containment procedure, which was very strict on this project. On-site cleaning trials were completed using both methods. However, the laser cleaning beam was quite small and took a skilled technician quite a long time to operate, hence making the procedure much more expensive and time prohibitive to deploy. The ferrous staining was removed with a chemical rust remover, being careful to collect it so that it wouldn't stain other areas of the facade. And a general detergent with water was used to clean the dirt and soot deposition on the surface. It was ultimately decided not to over-clean these panels and to use the milder cleaning solutions for effective rinsing of the panels. The mural that you see here is the Wayne Thiebaud mural, which is at the base of the building. Overall, the mural had some very light to medium soiling that could be gently cleaned using warm water and detergent. Overall, fortunately, the mural was in very good condition given its protection from the overhang above. I think what was decided after looking at this larger cleaning sample was that we could take a very gentle approach to really returning the mural to its former appearance. And here you can see a photo after completion. And then here you can see a photo of the entire facade with all of the areas cleaned. This includes cleaned and restored aluminum panels, tile mural, and the loci panels, which are at the top of the building. So just a few words here for some concluding remarks. As illustrated in this presentation and case study today, items to consider in most cleaning programs include establishing goals and criteria before and during the project, because sometimes things may change as you proceed through mock-ups and different types of evaluation. Should always consider the nature and condition of the substrate and the type of soiling that you're dealing with, because they vary from project to project. Always evaluate the cleaning systems for the specific application, whether it be water and steam, chemical, micro-abrasive, or if there is an opportunity to use a laser or even a combination of these systems. On most of our projects, we often find that we use a combination of systems, and it isn't always an either-or situation. Try to select the gentlest system, which is the most effective. And always, carry out trials and mock-ups. You can never do enough of those to evaluate the effectiveness for the cleaning program. Specify quality control measures up front through specifications and on-site with contractors, and then maintain those quality control measures throughout the project and the work. And so with that, thank you. I just have a couple of acknowledgments, just a few short words to say thank you to our colleagues here at WJE for providing different photos that were used as part of this presentation.
Okay. Thank you, Kyle, and thank you, Deborah. As a reminder, if you have a question, please type it into the Q&A box and hit submit. And if we don't get to your question during the call today, either Deborah or Kyle will follow up with you afterward. Okay, our first question. What's the most interesting surface you've ever cleaned and why?
Liz, I'm happy to answer it. The most interesting surface with which I was involved in cleaning was the Chagall mosaic, Les Quatre Saisons, in downtown Chicago. And it was inspiring to be helping preserve the mosaic, but it was also a fascinating challenge because of the rough mosaic texture, the different types of tile, and the mortar bed that it was set in. So it was quite interesting. Thanks.
I think I could probably add to that. I could probably add to that, Liz.
Yeah, go ahead.
I think the most interesting substrate that I cleaned recently was Tennessee marble with the lions at the New York Public Library. I think we were in a situation where we were able to use the most recent laser cleaning technology, which revealed the true color of the stone. I think a lot of people were really impressed that they could actually see the pink in the marble and not the soil deposition, which had been present for so long. So, thank you.
Okay, our next two questions are similar. What types of pollutants and stains do poultices best remove, and is a rubber poultice acceptable on marble?
I'll start, Kyle.
Okay.
Poultices effectively remove deep set stains, and they can really be used on any type of staining where a liquid cleaner or other techniques do not work. Poultices are also very good for interior cleaning where we want to limit the amount of water that needs to be used, and we're very excited about the newer waterless poultices that we've been trying. Kyle, do you want to comment on rubber poultices on marble?
Sure. We have done quite a number of tests using rubber latex poultices on marble, and we've had pretty good success with it. I will put a caveat with that, it's not just one application typically. Sometimes it's 2 or 3 applications to be able to obtain the level of cleanliness that you're looking for. So just, again, trials are very important.
Okay, our next question. How much do you worry about the quality of the water used for this process? For example, could using very hard water drive minerals into the stone?
I can start off with that one, Liz. Actually, the quality of the water does affect cleaning, and I think we haven't been so much concerned with hard water, although soft water, as anyone knows who's tried to wash something in very soft water, can make rinsing difficult. But we're more concerned about mineral content of the water, even if the water is only used in a minimal way. We usually specify an iron limit, for example, of 2 parts per million, and we specify potable water. In order to find out what the content of the water is, whether there are any additives in the system that may be contributing to staining, we need to get the test data. Most major municipalities test their water, but some rural locations, there may be no available test data, and you have to do the test.
Okay, a related question, what is considered to be high pressure?
We had a slide showing the range of pressures encountered in facade cleaning. Typically, high pressure for facades would be about 800 to 1200 psi, or 800 to 1000 more conservatively. But we would rarely use pressures that high except on very hard, very sound substrates such as concrete or perhaps granite. Typically, we try to stay under 800 psi, and for stone, particularly marble, we're often 100 psi or below. Marble can be etched even by moderate pressure water. It's also important how the water is delivered. We usually specify a stainless steel fan tip with 40-degree spread, held 12 to 18 inches from the wall. But again, it varies with the system and the substrate. And for context, hydroblasting to prepare a concrete swimming pool for a membrane can go up to 30,000 psi and well above that. So we're talking about quite low pressures for facade cleaning.
Okay, our next question. CO2 blasting was not discussed. Can you give your opinions on this technique?
Sure. Kyle, do you want to comment, or would you like me to?
Well, we've used and tried out CO2 blasting on a number of projects, and I think we've been able to get some visible results that were achievable, but we caution on the use of it, and you should really do trials to understand what you're dealing with.
I would add that you should do trials with anything, even water cleaning. But regarding CO2, and I think there's a related question about dry ice cleaning, the systems were originally designed to clean oil or grease from equipment, like steel equipment, and so they weren't designed for masonry facades or curtain walls and so forth. We have had some success. In fact, the paint removal that I showed in the paint stripper section, we also tested dry ice, and it was effective, but not as effective as the systems we ended up using. I have not seen it to be very effective, for example, on brick and terracotta cleaning.
Okay, our next question. Are there certain types of stone or metals that you would or would not use a sealer on after cleaning?
Well, I think in general, we try to stay away from putting sealers on masonry substrates. I think in some cases we might apply a water repellent, which is something that needs to be folded into a maintenance program because it requires reapplication. But putting in a sealer could trap moisture in masonry substrates, and we would tend not to specify that for most types of projects.
Okay, the next question. How abrasive is laser cleaning as it evaporates the surface buildup? Does it remove the original particles of the substrate? And if so, what is the acceptable rate?
I could start with this, Deborah.
Sure.
In terms of our evaluation of lasers, and it's quite common knowledge that lasers use light to clean the surface. So there's really no pressure that's applied to the surface, and it typically doesn't erode the surface. It's really using the radiation of the laser to ablate the dirt particles that are on the surface. And once they're ablated, they evaporate. So it's a very different type of cleaning technique from the cleaning techniques that we reviewed in this presentation, whether it be water or microabrasive or chemical cleaning, because they don't require any water and there isn't really any pressure that's applied to the surface. Hopefully that helps.
Okay, related, have you seen laser cleaning cause staining on ferrous containing masonry materials?
There's a big debate about the appearance of different types of metals with regards to the applications of lasers. Sometimes there is a particle buildup underneath in the patina layer, which then we've had to use a combination of poultices together with lasers to remove some of the staining that you might see once you remove the outermost layer of dirt. So I think, does the laser clean those yellow areas? Sometimes it stops just short of that, and you need to use another method to remove some of the oxidized metallic surfaces that are present.
All right, we've got time for one more question. In historic structures pursuing tax credits, what are the most frequently used cleaning methods and which methods should be avoided?
Well, we do quite a bit of work with tax credit projects, and I think the overarching guidance is pretty much the same, which is the cleaning methods need to be non-harmful to the substrate, not adversely affect the historic fabric. So I would say that overarching guidance of the gentlest system that's effective is really what pertains. Methods to be avoided should be those that can damage the substrate, but also that pertain to that present hazards or risks of any form. I hate to answer by saying it's a case-by-case basis, but generally in review of tax credit projects, usually the red flag is if an aggressive system is being used, and it just needs to be presented in the context of gentlest, most effective system. I hope that answers the question.
Thank you, Deborah. So that is all the time that we have to answer questions on the call today. We received many, many good questions, and as I said before, Deborah and Kyle will follow up with you if we weren't able to get to your question. Thank you so much for joining us, and thank you, Deborah and Kyle, for the great presentation. We hope it's been educational. If you have any questions, please don't hesitate to reach out to Deborah or to Kyle. Their information is on your screen. And if you have any questions about WJE webinars, please contact me, Liz Temper at ltemper@wje.com. So again, thank you so much for your time, and we hope you have a great rest of the day.